This is SpaceTime, Series 28, Episode 86, for broadcast on the 18th of July 2025. Coming up on SpaceTime, the youngest basaltic lunar meteorite ever found on Earth. Could hypothetical objects called dark dwarves be lurking at the centre of our galaxy, and could they help explain dark matter? And astronomers use adaptive optics to get a new view of the spectacular Carina Nebula. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists studying a 2.35 billion-year-old meteorite have filled a billion-year gap in the Moon's volcanic history. The ancient space rock, catalogued as Northwest Africa 16286, was purchased from a dealer in Algeria back in February 2023. Its provenance before that remains uncertain. What is known is that the 311-gram specimen has a unique chemical signature. The findings of its examination, presented at the Goldschmidt Conference in Prague, are offering fresh insights into how the Moon's interior evolved, highlighting the long-lived nature of its volcanic activity. The analysis lends weight to the hypothesis that the Moon retained internal heat-generating processes which powered lunar volcanic activity in several distinct phases. A lead isotope analysis dates the rock's formation to around 2.35 billion years ago, and that's during a period in which few lunar samples exist. And that also makes this the youngest basaltic lunar meteorite ever discovered on Earth. In fact, its rare geochemical profile sets it apart from those returned by previous Moon missions, with chemical evidence indicating it likely formed from a lava flow that solidified after emerging from deep within the lunar interior. The study's lead author, Joshua Snape from the University of Manchester, says lunar rocks from sample return missions provide fantastic insights, but they're limited to the immediate areas surrounding the mission's landing site. By contrast, lunar meteorites can potentially be ejected by impact cratering occurring anywhere on the Moon's surface. As such, there's some serendipity surrounding this sample, as it reveals secrets about lunar geology without the massive expense of a space mission. The meteorite contains relatively large crystals of the mineral olivine. The rock's a type of lunar volcanic basalt known as olivine pyric basalt. It contains moderate levels of titanium and high levels of potassium. In addition to the unusual age of the sample, the study also found that the lead isotope composition of this rock, that is, the geochemical fingerprint retained from when the rock first formed, points to it originating from a source in the Moon's interior with an unusually high uranium to lead ratio. And these chemical clues may help identify the mechanisms that have enabled periods of ongoing internal heat generation on the Moon. Snape says the age of the sample is especially interesting because it fills an almost billion-year gap in science's understanding of lunar volcanic history. It's younger than the basalts collected by the Apollo, Lunar and Chang'e 6 missions, but it's older than the much younger rocks brought back by Chang'e 5. He says its age and composition showed that volcanic activity continued on the Moon throughout this time span, and the analysis suggests an ongoing heat generation process within the Moon, potentially from radiogenic elements decaying and producing heat over long periods. Moon rocks are rare. This particular rock provides new constraints about when and how volcanic activity occurred on the Moon. This meteorite is one of only 31 lunar basalt meteorites officially identified on Earth. Its distinct composition, with melted glassy pockets and veins, suggests that it was likely shocked by an asteroid or meteorite impact on the Moon's surface before being ejected into space and eventually falling to Earth. Of course, this shock event also makes it more challenging to interpret the date obtained for the rock, but the researchers have estimated its age with a margin of plus or minus 80 million years. This is SpaceTime. Still to come, a new study suggests that hypothetical objects known as dark dwarves exist at the centre of the galaxy and could reveal the true nature of that mysterious substance known as dark matter. And astronomers use adaptive optics to undertake a new study of the western wall of the Carina Nebula in unprecedented detail. All that and more still to come on SpaceTime. A new study suggests that hypothetical objects which have been named dark dwarves could reveal the true nature of that mysterious substance known as dark matter. Dark matter is an invisible material that makes up around 80% of all the matter in the universe. Scientists have no idea what it is, but they know it exists because they can see its gravitational influence on so-called normal or baryonic matter. For example, it prevents galaxies from flying apart as they revolve, and it acts as a magnifying lens to amplify light coming from more distant objects behind it. But working out a way to identify what dark matter is has been problematic. Now, a report in the Journal of Cosmology and Astroparticle Physics come up with a hypothetical object which may well provide an answer. They've named these objects dark dwarves, not because they're dark bodies, but because of their special link with dark matter. One of the study's authors, Jeremy Saxton from the University of Hawaii, says that among the best-known dark matter candidates are what are called weakly interacting massive particles, better known as WIMPs. These are very massive particles that interact very weakly with ordinary matter. They pass through things unnoticed, don't emit light, and don't respond to electromagnetic forces, so they don't reflect light and therefore remain invisible, revealing themselves only through their gravitational effects. Now, this type of dark matter would be necessary in order for dark dwarfs to exist. The thing is, because dark matter interacts gravitationally, it could also be captured by stars, which have powerful gravitational fields, and therefore it could accumulate inside them. Now, if that happens, dark matter might also interact with itself, resulting in annihilation. Annihilation would release energy, and that would heat the star up. Studies like the one Saxton and colleagues are now doing are important because they offer concrete tools in order to break the deadlock on discovering what dark matter really is. So, what are dark dwarves? Well, ordinary stars like our Sun, for example, shine because of nuclear fusion processes which occur in their cores, generating huge amounts of heat and energy. Fusion happens when a star's mass is large enough so that gravitational forces compress matter towards the centre of the star, and they do that with such intensity they trigger reactions between atomic nuclei. This is nuclear fusion, and the process releases huge amounts of energy which we see as light. Saxton says dark dwarfs also emit light, but not because of nuclear fusion. They don't have enough mass to do that. In fact, they're very low mass objects, less than about 8% the mass of the Sun. And that's not sufficient to trigger fusion reactions. The answer are brown dwarfs. They fill a gap between the largest planets and the smallest red dwarf stars. And they do emit a faint light, energy produced by their relatively small gravitational contraction. The idea of this new hypothesis is that if brown dwarfs are located in regions where dark matter is especially abundant, such as, for example, the centre of our galaxy, then they could transform into something else, what Saxton describes as a dark dwarf. Saxton explains that the more dark matter you have around, the more you can capture. And the more dark matter ends up inside the star, the more energy will be produced through the annihilation of dark matter. Other candidates propose to explain what dark matter is are hypothetical particles such as axions or sterile neutrinos. But all these lack the mass needed to produce the expected effect needed for dark dwarfs. Only massive particles capable of interacting with each other and annihilating into visible energy could power a dark dwarf. Of course, this entire hypothesis would have little value if there wasn't a concrete way to identify a dark dwarf if you saw it. Saxton and colleagues propose a distinctive marker. He says while there'd be several markers available, he believes the isotope lithium-7 would be the best because it would have a unique effect. See, lithium-7 burns very easily and is quickly consumed in ordinary stars. So, if you're able to find an object which looked like a dark dwarf, you could look for the presence of lithium-7 in its spectra, because it wouldn't be there if it was a brown dwarf or a similar object. This is SpaceTime. Still to come, astronomers use adaptive optics to study the spectacular western wall of the Carina Nebula in unprecedented detail. And later in the Science Report, a new study is mapping killer whale populations in Australian waters for the very first time. All that and more still to come on SpaceTime. Astronomers using the International Gemini South Observatory have captured the western wall of the spectacular Carina Nebula in unprecedented detail. The amazing new image uses the process of adaptive optics, resulting in a tenfold improvement in sharpness in order to reveal a number of unusual structures within this amazing nebula. For astronomers, looking through the Earth's atmosphere is a lot like looking at the sky from the bottom of a swimming pool full of water. The atmosphere's density, temperature inversion layers, turbulence and composition all cause photons to bounce around. It's what makes stars twinkle in the night sky, which is great for romance, but not so good for astronomers. Adaptive optics works by using lasers to measure changes in the atmosphere directly above the observatory's telescopes. It then corrects for these changes using actuators to constantly change the shape of the telescope's mirror, effectively compensating for the atmosphere. With the help of adaptive optics on the 8.1 metre Gemini South telescope in Chile, astronomers have been able to study the Carina Nebula with new eyes. The brilliant Carina Nebula, located in the southern hemisphere sky, is some 500 times larger than the better-known Orion Nebula, making it an ideal candidate for investigating star formation. The astronomers' use of adaptive optics allowed them to significantly improve upon previous observations of Carina's western wall, the nebula's well-defined edge. The thing is, star-forming regions are shrouded in dust and gas. These are normally impenetrable to optical telescopes. But by looking through the infrared part of the spectrum, astronomers can see through this gas and dust. These latest observations by Patrick Hartigan from Rice University utilise the Gemini South's adaptive optics imager, a near-infrared adaptive optics camera, to peer through the outer layers of dust to reveal a huge wall of gas and dust glowing with the intense ultraviolet light from nearby massive young stars. Astronomers examined this region with the infrared wavelength of molecular hydrogen, 2120 nanometers. And molecular hydrogen is the best way to trace these structures because they'd otherwise be rendered invisible by dust blocking them at optical and ultraviolet wavelengths, which is where the Hubble Space Telescope operates. With a resolution 10 times higher than it would be without adaptive optics from the ground, these new images are twice as sharp as those from the Hubble Space Telescope at this wavelength, and they reveal a wealth of detail never observed before. The western wall is a mountainous section of the nebula, with a long series of parallel ridges that may be being produced by a magnetic field. There's a remarkable, almost perfectly smooth wave, and there are fragments that appear to be in the process of being sheared off the cloud by a strong stellar wind. There's also evidence of a jet of material being ejected from a newly formed star. Hartigan says the data in this new image provides the sharpest view to date of how massive young stars affect their surroundings and how they influence the star and planetary formation process. He says it's possible that the Sun and its planetary system formed in exactly the same sort of environment. If so, radiation and winds from any nearby massive stars would also have affected the masses and atmospheres of our solar system's outer planets.
Gemini South is a large telescope. It is 8 meters in diameter, and it sits atop of a mountain in the Andes in Chile. And what this instrument does is it allows you to get very, very sharp images of objects, because what it does, it actually distorts the shape of the mirror, so that compensates for any sort of shimmering in the Earth's atmosphere. And the other reason for going down there where you have to take the images in the southern hemisphere is that there are some parts of the sky that just are never visible from the north. Well, Carina is a very interesting area of star formation because it's probably the nearest star-forming region to us that has really, really massive stars. And that's very important because what the massive stars do, is they emit a lot of radiation, and that can actually affect the surrounding cloud out of which other stars are forming. These images really show clearly for the first time how star formation proceeds in regions that have massive stars, and an awful lot of stars form in those kind of regions. Ultimately, this is the story of creation, because what you're doing is you're looking at regions that are actually forming new stars and planets. So a couple million years from now, there will be new stars and planets there that don't exist now. And those will go through their lives and will be shining long after the Earth and the Sun have disappeared. In the meantime, the Sun will have thrown off its outer layers back into the interstellar medium, and then those provide new gases for new clouds, which then in the future form new stars. So there's this really large cycle of stellar life that is occurring. And what we're doing here is we're actually seeing into the stellar nurseries in very high detail through the dust, which is what the infrared light gives you. And you can really begin to see what's happening right at the beginning when stars and planets are forming.
That's Rice University's Professor Patrick Hartigan. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found significant levels of nanoplastics in water samples taken across the Atlantic Ocean. Nanoplastics are fragments of plastic less than a thousandth of a millimetre in size. A report in the journal Nature analysed samples taken from the top 10 metres of Atlantic coastal waters at a dozen separate locations. And the authors found that all these samples contained high concentration of nanoplastic particles. They say the average nanoplastic concentration at a depth of 10 metres was around 18.1 milligrams per cubic metre of water. Samples taken from the sea floor had an average concentration of 5.5 milligrams per cubic metre. And samples taken from near coastlines in Europe had concentrations of around 25 milligrams per cubic metre. The authors estimate that nanoplastic pollution in the top 10 metres of water in the North Atlantic is probably around 27 million tonnes. And that was previously thought to be the amount polluting the Earth's entire ocean system. Australians have one of the longest life expectancies on Earth, with the average Aussie living for around 83.92 years. But there are some steep socioeconomic differences. Now, a report in the Lancet Medical Journal claims Australia has made progress in reducing some of those socioeconomic inequalities in life expectancy, which were widening up until the late 2010s. However, the findings by the Australian National University show that although there was a narrowing of the gap in life expectancy across socioeconomic groups from the late 2010s onwards, the impact of the COVID-19 pandemic on women reversed that positive trend. In fact, overall, the authors found that the socioeconomic gap in life expectancy was larger in the period 2020 to 2022 compared to what it was between 2013 and 2015. Well, although they're well documented in the Northern Hemisphere and around Antarctica, much less is known about killer whales in Australian waters. That's a bit puzzling because orcas are actually commonly sighted year-round in all coastal waters around Australia. So now a new study by Flinders University has been mapping these toothed cetaceans in local waters in order to model their distribution and shed light on the local habitat preferences, in the process uncovering ecological distinctions between different killer whale populations. The Trump administration has followed through on the president's election promise, releasing tens of thousands of documents and records related to the assassination of President John F. Kennedy. And that public disclosure has now forced the CIA, America's main spy agency, to admit for the first time that an officer specialising in psychological warfare ran an operation that came into contact with Lee Harvey Oswald before the Dallas killing. The importance of this discovery is that the confirmation shows the CIA had lied for decades about its role both before and after the assassination. The previously hidden January 17, 1963 document is a CIA memo showing that George Jannetys, the deputy chief of the CIA's Miami branch, used the alias Howard Griebler. Until now, the agency had denied that Griebler was a cover name used for an operative working with an anti-communist group opposed to Cuban dictator Fidel Castro. In fact, for decades, the spy agency falsely claimed that it had nothing to do with this group, which was instrumental in having Oswald's pro-Castro stances publicised soon after the shooting. Jannetys oversaw all aspects of political action and psychological warfare, including covertly funding and directing the anti-Castro activists commonly referred to as DRE. In fact, it was four DRE activists who got into that now famous scuffle with Oswald in New Orleans when he was passing out pro-Castro Fair Play for Cuba Committee pamphlets. Interestingly, the Fair Play for Cuba Committee was yet another CIA-inspired operation. It was also the DRE who debated Castro on local New Orleans television in August 1963, which provided more media attention, setting him up and showing him to be a communist. A year earlier, the Pentagon had formulated a plan called Operation Northwoods. It was designed to stage a false flag attack on the United States, blame Cuba for the attack, and then use that as an excuse to attack the communist nation. These new documents still don't shed any fresh light on whether Oswald acted alone when he used his Mannlicher Carno rifle to shoot the president from the Texas Schoolbook Depository on November the 22nd, 1963. Or if the CIA hired a mafia contract hitman to act as a second shooter, so as to ensure Kennedy was neutralised to prevent him from undertaking two of his stated aims, breaking up the CIA and limiting American involvement in the Vietnam War. The thing is, these new documents do confirm that the CIA knew Oswald before the assassination. Tim Mendham from Australian Skeptics says the huge document release and the discoveries being made will keep conspiracy theorists, both those steeped in reality and the others, going for years.
People are still looking through them, and they're still trying to find the smoking gun, as we talk about.
Yes, still no evidence of a second gunman on the grassy knoll then?
None. No one's aware of it. And there's an article that came out recently by someone named Rebecca Watson, who's a known long-term skeptic, looking into a lot of the information there, especially looking into the film JFK. It came out 20 years ago, whatever. Looking at the JFK assassination, it had a lot of conspiracy stuff in it and a lot of false information in it that was being presented as fact. Despite how many years is it now?
November 1963, was it?
That's right. Yes, I'm old enough to remember it.
A friend of mine was actually a student in Dallas at the time, and she remembers exactly what happened on that day. The classes were stopped and they were all told about it, and they were all very sad, and the whole town sort of shut down, the whole city. And this is even back then, Dallas was a big city.
The one conspiracy you might get, this is sort of perhaps going on a tangent, if you could get out of the Kennedy assassination, was the rise of British popularity in the US, because, as people have said, the Beatles first arrived soon after their big tour. The first time they were in the US performing, Ed Sullivan Show, was early 64. And their sense of jollity and joy and excitement, etc., contrasted with the very gloomy US. And it's been written that a lot of young people, therefore, were very attracted to the Beatles because they were offering an alternative emotion to the doom and gloom that was sort of in a lot of parts of the US. So the Beatles come out, jolly mop tops, hair going, ooh, etc. And that led to the whole British invasion of music bands, and it changed the world of pop music, changed the world of music, and probably changed society a lot. So there is quite an amazing sort of, you can follow a social thread that might be an impact of the JFK assassination, apart from a lot of conspiracy thinking about how terrible governments are. They have found stuff which indicates the CIA were pretty crap at preventing it, that they had some information but they didn't do a very good job of acting upon it, so they kept it back for that reason, so as not to be embarrassing.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.